Bismillahirrahmanirrahim. So the next topic is associative mapping. We have two types of associative mapping. One is fully associative mapping or simple. So in previous example, this is main memory. Like a previous example, it contains two words 0, 1, word number 2 and 3 are here, 4 and 5 are here, and so on. 14 and 15. Total 16 words are in the main memory with 8 blocks. In the main memory, the block size is 2, so it contains two towards each line. So a processor access this cache. So what is then? For example, this is 0, 1, again 0, 1, word 0 and 1, 1. So the in direct mapping, we just the memory size here, the first are just identification of these two words in case of 2 or 3. So to identify individual word in the line cache line, the first W bits, least significant bits, are used. The next S bits are used for unique identification of cache lines. For example, we have 4 cache lines, so at least 2 bits are here required. If it's 16, so at least 4 bits are here to identify cache lines. And the rest are this block number are used take. So this was an overview of the direct mapping. But the disadvantage with the direct mapping, because for example, if I need a process which need a block number 0 and block number 4, both are coming to the same line. So for cache, it is not possible to occupy these two blocks in this at the same time, because the cache line number for both is same. So what is done, that when process request for 0 number block, it comes here and block 4 goes out, then block 4s come here and block 1. So again in out occurs and the number of misses increases. So this thrashing is this disadvantage of the direct mapping is called thrashing. So to handle this, the next one is associative mapping. So in associative mapping, it is possible that block 0 can come here or block 4 again come here. So for each block, the block number, the line number is not predefined. So this can go to any number. This is the main difference. So the simple definition of associative mapping: in associative mapping, the each block number of the main memory can go to any cache line, but we will need a replacement algorithm. For example, to which block should I replace? For example, block 4 is coming here, so the block number is not predefined, so it will see which one is not. For example, it can replace either 0 or 1 or 2 or 3. The number of it can go to either of these 4 lines. So for example, first in first out algorithm is a replacement. Which one is a replacement? In first in, it will see which one has more time in cache, so it will go and replace that block. Or which block is not used in the recent time, least recently used or least frequently used. So it's a different replacement algorithm. Depending upon these algorithms, the block 4 will replace any one of the cache line. So fully associative mapping can overcome this problem of direct mapping, which is thrashing. Memory block can load to any line, and the memory address interpreted as tag and word. Now there is no least significant, just tag and word. This is the memory address. Tag uniquely identified block of the memory. Every tag is examined for match. So need dirty and valid tag. Okay, dirty means the data has been changed in the cache, and valid means is not changed in the cache. So these tags are also important in the associative mapping. But the disadvantage is in direct mapping. You can see that, for example, I need block 0, so the CPU will just check only one line, because block 0 in case of direct mapping just go to single line. So if not present, it will go to main memory and bring it to the cache. But in associative mapping, the cache will the CPU will search full throughout the cache, where maybe it can be found here or here or here. So this is just the searching is expensive with fully associative. Here, for example, block 0 can come here, block 1 can come here, block 7 can come 0 here. So no issue. And this is tag. Dirty means, if this is dirty one, it means this data has been changed by the CPU. So before, if someone wishes to replace this, the data will move to the main memory. And valid means uh, it is not changed by in the cache. Okay, so the next one, so the direct mapping has a disadvantage of thrashing, and fully associative mean has disadvantage of uh, expensive in searching in the cache. So in direct mapping, the cache is divided into number of sets. Set contains number of maybe 2 lines or 3 lines or 4 lines. A given block maps into line in specifics. Use direct mapping to determine which set. So the set number is determined using direct mapping, and the within the set, this then it is associative mapping. If there are the number of lines per set is called way. 2 lines per set means two-way associative, and 3 lines per set means, okay, you can see in the next slide on the diagram, so it will be easy to understand. Here, for example, here we have 4 cache lines: line 0, line 1, line 2, and line 3. So the first 2 lines are grouped and called a set 0, and the next 2 are set 1. So suppose we have main memory 6 blocks, so the first 3 blocks are directly mapped to this, meaning that for block 0, 1, and 2, it must go to set number 0, and block 3, 4, and 5, each of this block, if block 4 want to go, it must go to sorry let me clear the screen. Again, here you can see set 0. So block 0 can come here, block 1 come here, block 2 come here, block 3 come here, block 4 come here, and block 5 come here. So these 0, 2, and 4, these 3 block comes to this set, and the remaining 3 blocks come to this set. So the set number is predefined like direct mapping using this formula J mod V. V is the set number. For example, I am calculating for 3. 3 is J. 3 mod total number of sets are 2. 3 divided by 2, 3 mod 2 is equal to 1. So the block 3 will go to set 1. So this thing is direct mapping, but within the, now block 3 came here, but here are two lines, so this is associative. Maybe black 3 can come here as well as come here depending upon the situation. So it will again need replacement algorithm. First in, first come, least frequently used, least recently used, etc. So here within the set black, there are two options for black 4, can come here or here. So this is called two-way associative. If the number of lines in each set is 3, this is called three-way set associative. If this is 4, this is called four-way set associative. So way associative means the number of lines in each set. If the number of lines in set is 0, each set is 2, it is two-way set associative. If the number of lines in each set is 3, it is three-way set associative. If the number of lines
this is
in each
just
set is 4, it is
the
four-way
address
set
structure.
associative, and so
First
on.
are the these bits are used for uniquely identification of the
World. The next, just like in direct mapping, these bits were used for each address. So here just set is predefined. So it must be enough to uniquely identify total number of sets in the cache, and the remaining are the tags. So this is all about k-way set associative. I already talked about this. Two-way set associative gives much better than direct mapping. Just one extra slot avoids tracing problem. So how does it allow? For example, 0 4. So you can, we have two-way set associative. So in both come same set, but 0 come to one line and 4 come to another line. So the thrashing problem can be addressed using this set associative. Similarly, four-way set associative means that the number of lines are 4 in each. It slightly better performance over two-way set associative. Further increase in the size of the set has little effect than other increase. So if you further increase, it just depends upon the situation, but it is not very good to increase the number of lines per set. It will reach, if we make only one set, it's just fully associative. Okay, thank you so much. Okay, I also just have a quick recap to first in, first out. Which line should I replace? It is also decided during the associative mapping. So general simple one is first in, first out. Replace those line which have more time in caches. First in, first out are least frequently used. Replace those line which is not recently used and not used again and again in the recent time, and so on and so forth. Similarly, we also have writing policies, write back and write through, which I already have in the previous video lecture. Please watch them as well.